Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us continue with our discussion of Gauss-Seidel method in numerically solving simultaneous linear equations. In the last video, we have shown an example which seems not to be converging to a true solution, to true result, okay, to the actual answer. So let's see what went wrong. Even though we did correctly the process, the procedure, the answer is not converging to the correct answer. This example illustrates a pitfall of Gauss-Seidel method. Not all systems of equation will converge. How can we fix it? One class of systems of equations always converge. One with a diagonally dominant coefficient matrix. Diagonally dominant means matrix A in A x is equal to C is diagonally dominant if and only if we have this condition satisfied. So for all I, we have AII must be equal or greater than summation from J is equal to 1 to N, wherein J is not equal to I of what? The summation of AIJ. Okay? So that must be equal or greater. Okay? And another one, another condition, AII must be greater than summation of AIJ, okay, for at least one I, okay, from J is equal to 1 up to N, wherein J is not equal to I, okay, okay, for at least one I. Meaning of one I is I is the row, okay, for at least one row, AII is greater than AIJ. While on the first one, first condition is for all rows, okay, AII must be what? Equal or greater. So there is no way that the AII must be less than, okay, must be less than. So that is what we mean by dominant. It could only be equal to, but not be more than with. Okay. So diagonally dominant, the coefficient on the diagonal must be at least equal to the sum of the other coefficients in that row, and at least one row with the diagonal coefficient greater than the sum of the other coefficient in that row. Which coefficient matrix is diagonally dominant? We have the two matrix here, which is the diagonally dominant matrix. We have B. Okay, this B, the diagonally dominant matrix. Okay, let's see. It's one of these diagonally dominant. The coefficient on the diagonal must be at least equal, okay, to the sum of the other coefficients in that row, okay. Row, so at least equal, so diagonally dominant. So the almost diagonally dominant, because if you add this one, this is 130, this 129. Okay. And at least one row with the diagonal coefficient greater than the sum of the at least one row. So this is the diagonally dominant coefficient. So at least one row. We have at least one row with the diagonal coefficient greater than the sum of the other. So there are actually two. So this one is greater than the other two, and this one is greater than the other two. So that's dominant. Okay. So most physical systems do result in simultaneous linear equations that have diagonally dominant coefficient matrices. Most physical systems, meaning those are following physics laws of physics. Okay? So let us remember that, and as an assignment, you have to do the computation here following these rules. Okay, what rule? You have to compute the sum of the other coefficient in the row and compare it to the coefficient on the diagonal. Okay, so by this, let us wait for the next video. This is Dr. DrEYPEI, preaching engineering for nation building.